I heard through the grapevine that NASA is planning to put a huge occulter in space, like 22 meters in diameter, to look at the contrast between planets and now to block out the direct starlight and to look at the faint reflection from the planets, and the contrast is like 10 to the 10th, by the way.
The terrestrial planetary finder, one of the designs is actually to have a disk blockage, and there are different ways of doing it. There's ways of doing it interferometrically, and there's ways of doing it physically, where you actually block the light from the star so that you could see the light from the planets. Because as I mentioned, especially in the visible, the difference in light between the planet and the star is like over 1 million.
10 to the 10th or so.
Yeah, it's much higher, depending on the wavelength. So in the infrared, that difference is only 1,000. So it's a lot easier to do.
Is there a possibility sometime soon of a quantum leap in exploration using nanotechnology and the breakthroughs in communications?
In fact, nanotechnology is a big field at NASA and as well in industry. And in fact, there are nanosatellites that are being flown. In fact, I think there were some test satellites for space science investigations that are either been initially flown or about to be flown or designed to be flown, built to be flown, which uses nanotechnology. Yeah, and I'll say a little bit more when I talk about Professor Villeneuve, but you know, I told you the distances that we have to travel, so we have to look for other ways to send signals, to information, to communicate. So yeah, these are all fields that people are working on, and I believe there will be some success in the future. And then if you look at the distances, and I mentioned some of this before, the farthest star is 12 billion years away. Actually, that's not the farthest star. That's the farthest star we've been able to see. Because the Big Bang that formed the universe was supposedly occurred about 13 billion years ago, something like that. And it expanded in all directions. So it's 12 billion to the center, but it's 25 billion to the other side. And so these are enormous distances. These are light years at the speed that I gave you before, traveling at 660 million miles an hour. It takes a whole year to travel that distance. Okay, closest galaxy. It's not Andromeda, which I showed. It's only 80 light years away. What does this mean? That means that when light left that object, it left 80,000 years ago. So when we're looking at this galaxy, or when we're looking at the farthest star may no longer be there. It was there 12 billion years ago. Because it takes that amount of time for that light to reach us. So we're looking into the past, and that's why it's so exciting to have these astro telescopes like the Hubble Space Telescope, which really doesn't study the present, it studies the past, our origins. And of course, these distances to work at Goddard, at DC and so on, you've seen before. So distances are important. So how do you make that leap? How do you develop techniques to do it? Well, maybe tachyons are the answer, because they're faster than light particles. And in theory, if you go that fast, according to Einstein, you go back in time. So we actually could get to the nearest star and be younger than we are today. Well, to go on to my other interaction, this was here at this embassy, the Ukrainian embassy in May of 2000. The president of the Ukrainian Academy of Arts and Sciences in the U.S. is handing over to then Prime Minister, Premier Viktor Yushchenko, the art archive of Volodymyr Vinnychenko. Volodymyr Vinnychenko's archive is being housed at Columbia University under the arm of the Ukrainian Academy of Arts and Sciences. But the idea was to transfer it to Ukraine according to the agreement and will of his wife. And that has yet to have happened. And it was very hard to do for various reasons. But Alexei Villeneuve was able to, during his tenure as president, to at least transfer part of that and fulfill Volodymyr Vinnychenko's wife's wishes. The other place I met and had quite a bit of interaction was in Ukraine. And here's an example. And this was a meeting, Astronomy in Ukraine 2000 and Beyond. This was in the year 2000. And the other interaction, of course, was about exactly 2 years ago, when Alexa Villeneuve gave his talk about the fiery crunch or frigid void. He talked about cosmological reflections and the ultimate fate of the universe, some of the things we've talked about here and had questions about. And it's kind of interesting how everything seems to come together, because I had this interaction with him. But it's very related to some very interesting work that was done at Goddard Space Flight Center, a NASA satellite called COBE. This is looking at the remnants of the Big Bang, which was very hot. All the energy was very hot, but it expanded over tremendous distances. And so the effective temperature now is not 10 to the 27 degrees, but it's really 3 degrees Kelvin, which is almost zero. And this satellite was able to measure this remnant, this noise, and its distribution, and try to give us more information about the origin of the universe. And in fact, for this work, a colleague of mine, John Mather, received the 2006 Nobel Prize in Physics. He shared it with another colleague, Smoot. And John is right here. And John happened to be a student at Swarthmore College. And in fact, John was a student of Alexa Villeneuve. Now, I mentioned this to him, and he didn't want me to mention this in the previous talks because he said, so what? So he's a Nobel Prize winner, and I was a professor, but so were others. But now I think it's appropriate to mention that, and I talked to John, and John sent me this email, and I could read it to you. It says that when I was young and slightly overwhelmed freshman at Swarthmore, Dr. Villeneuve quickly became my advisor in physics. I used to go to his office and talk about my courses and what I could do, and whether I was in the right school or not. He gave me a lot of very useful ideas, and he arranged for me to get some special attention from the faculty, so I could skip ahead in my classes to the latest and most exciting parts. I loved hearing about his sailplane exploits, and tried to imagine what it would be like, zooming all up and down the United States without a propeller, just feeling the forces of nature and steering around the clouds like a bird. It was all very enchanting, and he really helped me get going. He really helped me get going with what I really wanted to do. I thank him from the bottom of my heart.